Hi, it's Michael Grogan here, and in this video tutorial I'm going to be showing you how we can run an ARIMA model using stats models in Python. Now, in one of my previous videos I demonstrated how we can do this using the R platform, but here I'm going to be demonstrating how we can do it using Python. So basically, we're going to be forecasting a stock price, Johnson & Johnson, using the ARIMA model, and this is generalizable to time series forecasting as well. So what we're going to do, we're first going to load up all our files and all our libraries here. And what we're going to be doing is we're going to be using the statsmodels library in Python to be able to run the ARIMA model, but also to do things like run autocorrelation plots and the Dickey-Fuller test as well. So that's just going to take a little while to load all those libraries. So we'll just wait for that. Okay, perfect, that's been loaded. So now what we're going to do is we're going to use pandas to read in our stock price data. So as we go down here, you can see that we have all our 120 time periods of our stock price data. Now, before we actually get into the ARIMA model itself, what we're going to do is we're going to transform our data into logarithmic format. So stock price is essentially, because we are dealing in returns, we want to make sure that our data is actually in the right format. So when we convert to logs and when we actually plot the price in log format, you can see that this is the plot that we come up with, and it's going to give us more accurate estimates in terms of return because it's adjusting for volatility essentially. Now, before we actually run the ARIMA model, we want to make sure that our data is stationary, because if we don't have a constant mean variance and autocorrelation, we're not going to be able to make accurate forecasts. So when we run the ACF and PACF plots here, you can see on the autocorrelation plot we have a steady decrease downwards in the correlation for each lag. Now, when we run our partial autocorrelation function, you can see that we have a sudden drop in the correlation for the lags. So autocorrelation is a steady decrease, but partial autocorrelation is a sudden decrease. So this indicates that we have an AR1 process in our time series, a stationary AR1 process, which coincides with the way we want our time series to be structured, essentially. Now, once we've screened for that, a more formal test that we can do, as you can see in the code down here, ts.addFuller is the Dickey-Fuller test to actually carry this out. Now, I'm not going to be running the test in detail here. The code is on my website and you can run it if you wish. But you can see that the first difference autocorrelation has that up and down zigzag pattern that we would expect in a stationary time series. So once we run a plot of the first difference autocorrelation, it coincides with what we expect essentially. And we also expect that we would see a similar pattern for the partial autocorrelation that's also been first differenced. So just bear with me one moment. I'm just going to show the plot here. So the data is actually loaded in, but in Python we type in plot.show. It actually shows the plot. So yeah, and again you can see that we have that zigzag pattern again in terms of the partial autocorrelation once it's been first difference. So again, that coincides with what we expect. So now that our data has actually been prepared, what we're going to do is we're going to run an ARIMA model with the configuration 0, 1, 0. Now, in R, you could specify the ARIMA configuration automatically, but here we're going to do it manually. And basically, we're choosing the 0, 1, 0 configuration because we see a particular trend in our time series data. So if we go back up and look at the log price here, we can see that we have an overall trend to the upside. And when you have an overall trend in a time series model, whether it's to the upside or the downside, a lot of the times it will actually be in this configuration 0, 1, 0. So we're going to run the ARIMA model and we're going to forecast for the next 5 time periods outwards. And when we actually run this, what I'm going to do is I'm just going to show you the ARIMA model results and also the forecasted price. So you can see that we have a straight line upwards. So the 010 is forecasting the price upwards for those 5 time periods. Now, on my website, I go into more detail as to how you can actually validate this data against what we're actually getting, etc. But essentially, to run an ARIMA model in Python, this is how we would go about it, and this is how we would actually conduct a forecast based on the time series data that we have. So to summarize, what we've covered is we've seen how to prepare our time series data, particularly if we're working with stocks. We've seen how we can run the autocorrelation and partial autocorrelation functions in Python. We've also seen how we can do a formal test for the Dickey-Fuller, and again, you can refer to the code for this if you want to delve into it in more detail. And we've also seen how we can forecast a stock price with an ARIMA model, but that's generalizable to any time series. So many thanks for watching, and as I mentioned, the code and the content is available on my website, and feel free to try this out yourself and see what you come up with. Many thanks.